Hey Mathwits! Today we're going to do more of multiplication. Let's start out with a practice problem. Let's do 6 times 7. We know that our base number is 6 and that we'll have 7 sets. 1, 2, 3, 4, 5, 6, 7. So, our first set has 6. Our second set has another 6. 6 plus 6 is 12. 12 plus another 6. 13, 14, 15, 16, 17, 18 plus another 6. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. We know that 6 times 7 equals 42. But that took a long time to figure out, which is why multiplication and understanding the process is so important in seeing patterns and counting to higher numbers. While using an array is a good way to visualize multiplication, it's not always needed to do the process. To do multiplication quicker, we often use a times table to help us understand what times what equals what. As you can see, all of the single-digit multiplication problems are written out on this chart, from 1 times 1 to 9 times 9. If you look down the answer side of each of these equations, you can see that there's a pattern. In the 1s, the answers go up by adding 1. In the 2s, by adding 2s, the 3s by adding 3s, and so on until the 9s add 9s for each answer. Let's do an example using this chart. Let's say we want to do 1 times 7. Well, instead of drawing out an array and using blocks to count up to 1 times 7, we can use this chart and find this somewhere on this chart. Our first number is 1, so we'll look in the 1 area. We're multiplying it by 7, so we'll go down to 1 times 7. 1 times 7 equals 7. As we learned in the last video, anything times 1 equals that number. Another example of using this chart would be 6 times 9. Our first number, 6, is right here. And we're multiplying it by 9, so we'll find 6 times 9. That equals 54. As you can see, this is a lot simpler and a lot faster than counting out 9 sets of 6. If we wanted to do 8 times 8, instead of adding 8 to itself 8 times, we can just look on the chart and find 8 times 8, which equals 64. Knowing your times tables is fundamental to knowing multiplication, so memorizing this chart would be really helpful. One way to memorize would just be to practice lots and lots of different equations like this on your own, and referring to the chart whenever you need help. Another way people memorize is through using sequences. Sequences, as I said in the last video, is going through a list of numbers with a pattern, which we can see are the answers to all of the multiplication equations. So, if you wanted to memorize your 4s, you could go 4, 8, 12, 16, 20, 24, 28, 32, 36. And memorize that list so that you don't have to count up to 36 every time you wanted to know 4 times 9. As we know, multiplication is repeated addition, but they have more similarities than just being a better use of addition. In addition, you can do a problem like 3 plus 7, and we know that equals 10. We also know that if we switch these two numbers, it equals the same thing. So if we did 7 plus 3, that still equals 10. This property also works in multiplication. So if we wanted to do, let's say, 5 times 6, we can see that 5 times 6 equals 30. If we switch these numbers and made it 6 times 5, we can see that 6 times 5 also equals 30. This is called the commutative property. C O M M U T A T I V E P R O P E R T Y. The commutative property states that in addition and multiplication, it doesn't matter what order your numbers are in, as long as they're being added or multiplied by each other. This isn't the first property that we've learned. We've also learned that anything times 1 equals anything. This is called the identity property. I D E N T I T Y. And there's also anything times 0 equals 0. This is called the zero property. Z E R O. These properties are true no matter what numbers you have. That's it for today, Mathwits. I hope this helped understand more concepts surrounding multiplication. I'll be linking a multiplication chart in the description that goes from 0 to 12. Thanks for watching.